So one-size-fits-all models like GPT-4, ChatGPT, or Claude, or something like that, these models are great. And they've sort of sparked this gold rush that I think is the reason a lot of us are sitting here, where businesses are searching for ways to use these models to optimize their internal processes and deliver exciting new experiences to their users. But these models that are designed to do it all can't do everything. There's still a lot of use cases for personalized, individualized models. If you need an LLM to do something very specific, you need an output in a specific format, or if you need to utilize some important IP that you don't want showing to OpenAI, then you need to start looking at fine-tuning these models at some point. And it's not difficult to see how this might end up scaling to billions of LLMs around the world. Maybe every consumer of an Apple product ends up having an LLM fine-tuned just for them on their personal tastes. Or maybe every business around the world, in every language, ends up fine-tuning an LLM for processing internal documents of every type. Now, this is exciting, but it raises an obvious challenge, which I think is a challenge that a lot of people here at MLOps World might understand, which is where are we going to put these models? LLMs are famously extremely difficult to work with. They're very large, and they're very computationally expensive. And if you have billions of these things, it raises the question of where are you going to put them? There probably aren't enough GPUs in the entire world to host an individual language model for every possible use case that you can think of. And so the question comes in how are we going to deal with this? Well, it's been known in the community for a while, and we actually have already seen someone talk about it on stage, that when you fine-tune models, you don't need to create a copy of the model from scratch entirely. With as little as 1% of the model parameters, you can change a model quite substantially into doing your task using things like low-rank adapters or other parameter-efficient fine-tuning techniques. In this way, you can fine-tune a model without requiring the full 100 gigabytes, let's say, to be replicated on every single GPU that you need. Instead, maybe you only need a measly 1 gigabyte of model to be changed, and that's the only thing that you need to load up every single time you want to inference a new model. So you can imagine this scenario where you have thousands and thousands of low-rank adapters or other parameter-efficient models sitting on a GPU waiting to be called. But the problem remains that, in fact, you can only do that one at a time. Only one such adapted model can exist running on the GPU at any one time, and all the others are left. So if you have thousands of users, each with thousands of fine-tuned models, when one makes a request, they're the only one that can be serviced. So once again, you're stuck. Either I have thousands of GPUs running in parallel servicing all of my use cases, or I have a big queue of users waiting for their requests to come in, and I hot swap the new models in and out. But there's actually a better solution than this. And I first saw it on Twitter, which seems to be the place that all good ideas are spawned now. And it's an idea called batch LORA. You can actually run these models in parallel by making a few tweaks to the model definition, writing some CUDA kernels. You can get it so that different models sitting on the same GPU that do entirely different downstream tasks and are fine-tuned differently can be run in parallel, service multiple users and multiple downstream applications at the same time on a single GPU. So you can picture one GPU, one A100 maybe, running a Llama 13 billion, let's say, servicing not just thousands of downstream users, but thousands of downstream applications, each one fine-tuned to do something completely specific, maybe in a different language, maybe to do a completely different task, chatbots, document extractors, all in parallel. I like to think of this as having like a single Llama model with multiple personalities, hence the sort of three-headed Llama dragon. And you can imagine this can cause a cost decrease of thousands if you can have 1,000 applications running on one model. And I view it a bit like a CDN of llamas. You could have a distributed network of llamas running on different hardware. And when a user makes a request and wants to run an application, you find the nearest application or the nearest node that has your application saved on it, and you can run all of these in parallel and save a lot of money. So my name's Jamie, and I'm here at MLOps downstairs if you want to talk more about this. Thank you.